Hi, this is Mr. Manley. This should be a pretty quick video reviewing solving a system of inequalities with two or more inequalities. Here I have three. We're going to graph these on an XY axis and see where they all overlap. Something that I like to do when I have a system of inequalities like this is to number them. 1 and 2, 3. And that way, whenever I'm doing any work with any of the inequalities, I can number it and anyone would know what I'm talking about. For instance, if I just take this first one here, that y is greater than 8, and I think about my scale, what's going to make sense here? Like, I would not want to do a scale like that. Y is 1, because I'm going to go 1, 2, 3, 4. I'm not going to have any room. So I don't know what scale is going to work on this, actually. It looks like it's going to be pretty difficult, but let's see if I can work it out. That if I'm going to say that my y scale is 2, there's my y-axis. And if I go up to 8 on the y-axis, let's go ahead and use a different color. So I'll go up to 8 on the y-axis. And here I have y is greater than, so I want to dash the line because that line is not included in the solution. And y is greater than, that should be obvious, right? That we're going to be looking up here, shading up here. So all the points up in that direction, those are all part of the solution. Then taking the second one, something that I'm going to do here is, what I like to do is find the x and y intercepts. I'm going to set up a table here, and you'll see how numbering this also helps when I set up the table, because I can say in the table here that I'm going to be doing number 2 when x is 0. That's easy. X zeroes out, and y would be equal to -6. Of course, we're looking for the edge of the solution, so we're not concerned about the greater than or equal to at this point. We're just saying y is equal to 6, and this is going to help give us the edge of the solution. And then when I let y equal 0, solving for x, I would get -3, right? So 0, actually let's take that 0 off there. All right, 0 for y, and then x would have to be -3. And hopefully you can see that pretty easily, right? If that's 0, if that left side's 0, what would x need to be so that the right side would be 0? Well, I would need 6 minus x to be 0, so x would need to be -3. Right? And then because I've numbered things, now I can go like this, and I can put a 3 and say, these next set of points are for the third inequality. And that will be when y is 0, when x is 0, y is 6, and when y is 0, x is -6 over 5. So again, I'm just thinking if that were zeroed out, and then I would subtract x and divide by 5. So I'd subtract -6, I'd subtract 6 and divide by 5 and get -6 over 5. Okay, let's graph what we've got here. I've got a -6. I'm looking at number 2 here. So I got a -6 and a -3. All right, looking at my x scale, you see I'm going to need a -3 and I'm going to need a -1 1/5. So I have a little bit of room to work with here. Maybe I could go like this and call this -1. -2, -3. Okay, so for the second inequality, I had the 0, -6, and then I'm going to have the -3, 0. We want to connect those points. That's going to be a little problem. Let's try that. Okay, that's pretty good. And in this case, it's y is greater than or equal to. So I'm going to leave the edge solid. Okay. Where do I shade? Well, one thing is I could look at point 0, 0. But I can also think about, I've got y is greater than. So y is greater than, that's clearly shading up. And if I checked point 0, 0, I would see they intersect there. So this is, and then I'm shading above that edge there, and it's going to go up across that line there, and that's where they're going to overlap. So somewhere out here to the left, and unfortunately my scale is kind of not ideal here, but somewhere out here to the left, these 2 points, and I'm going to use a different color, like say I'll use purple. Somewhere out here they intersect. And then the overlapping region is all of this stuff up here. Everything up here. Kind of covering up some of my inequalities there. Let's uncover those. Okay. Then inequality number 3 has an intercept at 6, 0, 6. So that's 1, 2, 3, 4, 5, 6. So that's up here somewhere. 0, 6. No, it's not. My scale was 2, right? So 2, 4, 6. That's here. There's where my 0, 6 is. And then -6 over 5, -1 1/5. So somewhere, maybe I'll do a different color again because it's getting a little obscured here. Somewhere around, right next to the -1, right? Would be -1 1/5. And I want to connect those points. I think I'll stay with this purple color. So that is going to go through that point and extend up that way. And through that and then down. Y is greater than. So we have to dash that. Dashing the purple line. All right, and then y is greater than. Again, that's above, right? That's going up. So I want to be above this line, up here. Like that. All right, and what I'm looking for is where do all 3 arrows, converge? And all 3 of those arrows are converging. Maybe with another color here. They're all converging in here. All up there. That's where they're all converging. And then it's along this edge here. That dashed edge there. And then this dashed edge here. And there's this corner. It's called a corner point out here. There's a corner point there. And I'm just going to do a little cross hatch here so it's a little bit more clear. And that's where the solution is. And then it just continues infinitely upwards. There's no upper limit. But the bottom here, we have those barriers at the bottom. And then off to the left here, which we can't see, there is an angled barrier off to the left because of this inequality here. So the scale was a little bit tough there for us in the space that I had to work with. But you see, we're looking at the edges. We're finding these corner points. We're going to find that's important in some concepts or a topic later on. And the overlap, the corner points, and then the edges, of course. And that's a system of inequalities with two or more equations.